Welcome. Today we're going to be learning about exponents. So I'm going to write that down right now, exponents. Before I tell you what they are, I'm going to first show you some examples of exponents. So we have 3 to the power 2, which is equal to 9, 4 to the power 3, which is equal to 64, 2 to the power 3, which is equal to 8, and finally 5 to the power 2, which is equal to about 25. I encourage you now to pause and try to find the pattern. Some of you might be wondering why 3 to the power 2 is equal to 9 when you know 3 times 2 is equal to 3 plus 3, which is equal to 6. And you know because you're multiplying by 2, you're adding 3 2 times. Now, where do we get 9 here? The exponent is a number at the top. It's similar to multiplication where you know how many times to add the number to itself. With exponents, you know how many times to multiply the number by itself. As you can see here, 3 to the power 2 is equal to 3 times 3, which is equal to 9. 4 to the power 3 is equal to 4 times 4 times 4, which is 4 multiplied by itself 3 times, which is 64. 2 to the power 3 is equal to 2 times 2 times 2, which is equal to 8. And finally, 5 to the power 2 is equal to 5 times 5, which is equal to 25. Let's go over a tougher example. What if I told you 2 over 5 with parentheses times ... times 2 over 5 is equal to 2 over 5 with parentheses to the power 3. I have a ... here because I don't know how many times I have 2 over 5. My job right now is to try to figure out how many times I'm multiplying 2 over 5 by itself. Well, I see the exponent here and it says 3. So I think, 2 over 5 is multiplied by itself 3 times. Now, you might be wondering why the parentheses stayed there. Let me show you, using this next example, why parentheses are important. Let's say JP says minus 1 times minus 1 times minus 1 times minus 1 is equal to minus 1 to the power of 4. The question is he correct? Remember, the first step we got to do is always annotate. Always annotate whenever we see something like this. So what we're trying to find here is whether or not JP is correct. Let's start by multiplying them together. We're going to go one by one. Let's start with minus 1 times minus 1. We know that minus 1 times minus 1 is equal to positive 1 because minus times minus is a plus. Now I'm going to add a plus sign and parentheses even if it's not necessary here. Now, let's move on to the next one. We have minus 1 times minus 1 times another minus 1. I'm going to put the first two minus 1s in green because that's what we've already done. Now we're going to multiply the third one to it and we're going to see what comes out. We know that when we multiply a positive times a negative, we get a negative number. So, as a result, this whole thing, minus 1 times minus 1 times minus 1, is equal to minus 1. Cool. Now, we're going to do minus 1 times minus 1 times minus 1, which we've already done. So I'm going to put that in orange. And then we're multiplying another minus 1 to it in blue. So we have all 4 minus 1s already. When we put them together, we get minus 1 times minus 1 because we've already done the first 3. We know it's minus 1. The last one is a minus 1 as well. And when we do minus times minus, that's negative times negative, which becomes positive. So this whole thing is positive 1. Cool. Now, let's look at what JP wrote. He says this whole thing is equal to minus 1 to the power of 4. Let's see exactly what that minus 1 to the power of 4 is. Minus 1 to the power of 4 means that the exponent 4 only acts on the 1. It thinks you're multiplying positive 1 by itself 4 times. So we get minus 1 to the power of 4 is equal to minus parentheses 1 times 1 times 1 times 1, which is equal to minus 1. Because that whole thing inside the parentheses is 1. You multiply a minus sign to it, you get minus 1. But that's not what we want. We want a positive 1. It turns out the best way to put this positive 1 to express this is to use the parentheses as they are, and then we're going to keep the parentheses at the very end. We do minus 1 parentheses times minus 1 parentheses times minus 1 parentheses times minus 1 parentheses, which is equal to, you guessed it, parentheses minus 1 and the whole thing to the power of 4. So JP should write minus 1 to the power of 4 with parentheses around the minus 1, which we know is equal to 1. Cool. So let's review. First, you know when you have an exponent, you are multiplying a number by itself. So for example, if we have 2 to the power of 4, that's 2 times 2 times 2 times 2. 2 multiplied by itself 4 times, which gets 16. Finally, when working with exponents, parentheses are super important. When in doubt, just use the parentheses. For example, if you have minus 3, parentheses to the power of 2, you get minus 3 times minus 3, which is equal to 9. Now finally, let's go over some vocabulary to wrap things up. We have here x to the power of n. That's read x to the power of n. Power is a really important thing here, where n is the exponent of x and x is the base of n. These are some terms that we're going to be using throughout this module, so it's really important that you learn these now. Some common terms to know are that x to the power of 2 is read as the square of x, or x squared. And finally, x to the power of 3 is the cube of x, or x cubed. The reason why is because when you have a square, you should think length times width. That's the area, right? But notice how a square, you're multiplying each side by itself because the sides are the same length. With a cube, it's the same logic, except suddenly you're doing length times width, and finally you're doing height as well. So you are multiplying each side by itself 3 times. The length, the width, and finally the height. Cool. That's it for today. See you tomorrow.